Hey guys, my name is Neel and welcome to Neel Workshop Zone. So in this episode we are going to be talking about mole. So in a previous episode we talked about mean and the different types of to solve, the mean. So for example we talked about step deviation method, assumed mean method, direct method. So if you haven't checked that out, I recommend checking out those previous episodes because there is some information that will be used in this episode as well. So without any further ado, let's talk about it. So how do you solve a mole? So to understand that, we obviously need an example. So right here I have an example with me. So let's use this example to solve the mole. So the first question is, the following table shows the ages of patients admitted in a hospital during a year, and they gave a table. So let's just draw a table. And let's draw 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Here let's write age. Let's write number of patients. Let's write 5 to 15 and 15 to 25, 25 to 35, 35 to 45, 45 to 55, 55 to 65. And let's write down the value 6, 11, 21, 23, 14, 5. So, now that we have written this question, now let's actually try to solve it. But before we try to solve it, there is also one important thing. So, in this number of patients, first you have to see what is the highest frequency. So here the highest frequency is 23. And over here the age that is related to this is 35 to 45. So since it's 35 to 45, the model class which will be used in this formula is 35 to 45. So let's take this as the model class and let's use that as well. So now let's actually write the formula. So now that we have written this, like I said, let's write the formula. So mode is equals to L, and let's write here plus L plus F1 minus F0 by 2 F1 minus F0 minus F2 into H. Let me take the eraser right here. So now that we have written the formula, now I actually try to solve it. So L over here represents the lowest limit in the model class. So L here stands for 35. So let's write 35. Next let's go to F1. So F1 is actually this, the frequency. So the highest frequency is 23. So 23. Now it comes as F0. So the frequency is F1, and if frequency is F1, then what is F0? Well, F0 is a predecessor of this frequency. So for example, F1, F0, because it's the previous one, 21 will be F0. So 23 minus 21 by 2 of F1, so you need that multiplication of 2. F1 is 23 minus 21 minus F2 is the next value, the successor, which is 14. So 14 into H. So H is, like I said in my previous episodes, the difference between the highest limit and lowest limit in a pair of value, or the difference between them. So for example, in 5 and 15 the difference is 10, and even if you subtract the highest value from the lowest value, which is 15 minus 5, is equal to 10. So H over here is equal to 10. So now that we've written that value, now let's actually try to solve it. 35 plus 22 minus 21 is equals to 2. 2 by 2 into 23 is 46. 46 minus 21 is 45, 35, 25. 25 minus 4, 21, 11. So 2 by 11 into 10. So now let's continue over here. 35. So 10 into 2 is 20. So 35 plus 20 by 11. So now let's actually do this. 11 by 20. 11 1 is 11. 1, 0, let's add, sorry, I meant 9. Let's add another 0. So 11 8s are 88. 2. And it goes on, so let's take 1.8 as the default value. So here, the 20 plus 11 value turns into 1.8. So 1.8. So the answer is 36.8. So that is how we find out the mode by using the formula L plus F1 minus F4 by 2F5 minus F4 minus F2. So now that we've done this, let's actually do another example to still more understand this. But this time let's actually try to do it a lot more faster instead of more explaining. So let's see. Let's erase these as well. Let's just erase these and let's draw 2 more or 3 more. So now that we have drawn that, let's actually fill in these values. So the question now is the following data gives the information on the observed lifetimes in hours of 225 electrical components. So this gives us the observed lifetimes of 225 electrical components. So how much time they work? So let's write frequency and let's write lifetimes. Let's write 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100, 100 to 120, 10, 35, 52, 61, 38 and 29. And like I said, the formula is L plus, let's write F1 minus F0 by 2 F1 minus F0 minus F2 into H. Let me put this over here. So now that we have written the question, let's actually try to solve it as fast as possible. So L, which is the lowest limit, so we have 6 to 1 as the frequency. So the lowest limit over here is 60, so 60 plus F1 is the frequency, 61 minus 52 by 2, 61 minus 52 minus this, the successor F2, which is 38 into H, which is 20. So now let's actually do it. 60 plus 61 minus 52, we get 9. 9 by 2 into 61, we get 61, 120, 122, 122 minus 52, 120, 110, 90, 100, 90, 80, 70. 70 minus 38 is 62, 50, 40, 32. Let's take the eraser for a second. 32, I think. So into 20 to 20, 180. So I'm continuing over here. 60 plus 180 by 32. Let's actually do it over here. So here's the rough work. 32 divided by 180. So 32, 35 is 15. So let's take it as 5. 35 means 35 is 15. 160. 20 will be left. 0.100. 160 plus 6, 5.6. So the answer will be 160 plus 32. 192, 80, 64, 2. Let's add 2 over here. 64, 74, 16. Another 0 will be 160 and 625. So the answer is 5.625. So by adding 60 plus 5.625, the answer will be 65.625. So yeah, the answer is 65.625. So yeah, that is how you solve mode. I hope you enjoyed this example. If you did, don't forget to like, share, subscribe, hit the notification bell so you don't miss out any new videos. And that's all folks, and see you in the next one. Bye bye.